Hi guys, welcome back. So today we are going to be jumping into our Unit 1 Lesson 6 on fusion and fission. You guys will be doing this lesson independently and then taking the rest of the day just to work on any kind of assignments that you need to get turned in. I want to make sure you guys have plenty of time to get that done before your test that's coming up next week. So today's lesson is going to be on fission and fusion in relation to the sun. And by the end of the lesson, you should be able to compare and contrast fusion and fission, and then understand the process that fuels the sun. So before we get started, let's just do a really quick review of our seasons. So just a reminder from yesterday's lesson, the Earth rotates on its axis. So one full rotation equals 1 day, so 24 hours is a day, and that is due to the rotation of Earth on its axis, okay? The Earth revolves or orbits around the sun, and this takes 365.25 days to revolve. And that extra 0.25 days, remember every 4 years we have a leap year to make up for that extra time. Okay, so again, rotation on its axis, revolution around the sun. So why does the revolution matter, and why does the tilted axis matter? So the Earth's tilted axis allows us to have the seasons, and the 4 seasons are also based on the Earth's position to the sun. So in spring and summer, definitely in summer, you are tilted towards the sun and you're receiving more solar radiation, so that causes the warmer temperature. And then in the winter, you are tilted away from the sun and you are receiving less solar radiation, which leads to lower temperatures, okay? The seasons are caused by a combination of the revolution around the sun and the tilt of the axis. However, if I were to ask you, what's the primary reason for the seasons? It's the tilt of the axis. Because if the axis was straight up and down and Earth was not tilted, we would have the same season all year. Okay, so the tilted axis is the primary reason for our seasons. Okay, and this is kind of everything I just went over. So now that we've reviewed our seasons, let's go ahead and jump into solar radiation. So we learned yesterday for the seasons that when you're tilted towards the sun, you get more solar radiation, which leads to higher temperatures, ergo summer. And then when you have less solar radiation, when you're tilted away from the sun, there's less sunlight, less radiation, cooler temperatures. But what is solar radiation anyway? Okay, so if we break it down, solar is of or derived from the sun, and it's related to or caused by the sun. So if we look, this electromagnetic radiation here is coming from the sun. Radiation is the emission of energy as electromagnetic waves. Okay, so radiation hits the Earth in waves. You cannot see this, it's not visible to the naked eye, but we can feel it as heat. Okay. So solar radiation is the radiant energy of the heat and light from the sun. Now the light energy you can see with your naked eye, but the heat you can feel. Okay, here's a little crash course video for the sun if you want to take a look at that. So the main things that we're talking about today are nuclear fusion and fission. Okay, we have to know the difference. And so I just want you to pay attention for these next few slides and really try to take in what I'm saying. Nuclear fusion is what occurs in the sun. Okay, this is a chemical reaction that's happening, that's occurring in the sun, and this is what actually gives the sun its fuel and what translates into the solar radiation that we feel on the Earth. Okay, so fusion is the process which produces light and heat in stars, such as the sun, by smashing together lightweight atoms. Okay. So what I need you to understand is that fusion happens in the sun. It's where radiation comes from, and it's when atoms collide. So if you think about fusion, fusion means to come together. So fusion is the smashing together of the atoms. And I know you guys haven't had chemistry yet, so it won't make a lot of sense to you. I need you to just know the basics, that the fusion is the coming together of the atoms, and then it's causing the radiation. And I need you to know that fusion happens naturally in the sun. Okay, so this example here, we've got our hydrogen and then another hydrogen coming together. So we've got this hydrogen that's got 2 neutrons and this hydrogen with 1 neutron. They come together and smash together to form helium, and then energy is given off. Okay, so this is a reaction. What I need you to know again is that fusion is when the molecules push together, causing radiation, and that fusion is what happens on the sun or in the sun. Okay, and then if we break down nuclear fusion, nuclear is of or relating to the nucleus, and then fusion is to combine or fuse. So I know I've said it a million times, but I'll keep repeating it. Nuclear fusion, the atoms are smashing together. The energy of the sun is the result of that reaction. Okay? It's the result of that reaction, and that's where our heat comes from. Fusion, coming together, happens in the sun. And then here is a video that will show you that process. So just some basic chemistry for you. An element is any of the more than 100 substances that cannot be made by ordinary chemical means to be separated into different substances. And then the atom is the basic unit of matter. We've talked about the atom a little bit when we talked about the Big Bang. And it's the defining structure of the elements. So it's made of protons, neutrons, and electrons. Our hydrogen is the lightest element, and our helium is the second lightest element. So if we look back into fusion that's happening in our sun, remember these lightweight atoms are smashing together and emitting energy. Okay, I'm not concerned about you guys knowing this by heart. All right, this is just some background information. As long as you can tell me the difference on a basic level, the difference between fusion and fission, you'll be okay. Right? So then the last thing we're talking about is fission. So if fusion is coming together, fission is going to be breaking apart. Okay, this is the process of splitting a heavyweight atom, such as uranium. This is used on Earth for nuclear weapons and to produce electricity. So fission just means to separate, break apart, or fizzle out. So what happens with nuclear fission, this is actually what happens in nuclear reactors. So to make energy, you have a heavyweight atom. Typically it is uranium. It's particularly uranium-235. But you bombard it with these neutrons. So you kind of like, the thought is just to hit it really hard. And when that happens, the neutron breaks off, and then you've got these products that break off and eventually can be used to produce energy. And this is also what are in nuclear weapons. So when you talk about nuclear bombs exploding, nuclear fission is the process that causes that to happen. Okay, so fusion, the heavyweight atoms coming together. Energy is a byproduct that reaches the Earth as solar radiation. Fusion naturally occurs in the sun. Okay, fission is something that humans do. Okay. Nuclear fission is a human process, okay? We do it to separate heavyweight elements. So I need you to be able to compare and contrast the two, all right? And once again, I'm going to say it one more time, and then I'll be done. Fusion, atoms coming together, happens in the sun, natural occurrence, gives us our solar radiation. So think of fusion coming together. Fission, splitting atoms, man-made, breaking apart. Okay? If you can tell me those two differences, you will be fine for fission and fusion. Okay? And that's all I have for you guys today. Make sure that your notebook pages are completed, and then you will spend the rest of the time today catching up on any assignments that you need to make up. Go back into Canvas. I've already graded some things, and I've put some feedback on your assignments. A lot of you did not share correct links with me, so I need access to be able to grade your assignments. If you do not share a link that I can actually view your assignment, it's just going to be a 0. So I need you guys to share that with me, and then you can work on composing your interactive notebook and making sure it's organized. If you guys have any questions at all, make sure that you let me know. We're getting really close to your Unit 1 test, and I just want to make sure that we are all successful and ready to go.